Hello, everyone, and welcome to another Microsoft Reactor live stream today. Good morning, good evening, good afternoon, wherever you are in the world. We are very happy that you're joining us, myself, and Alan Smith, who is our speaker today.
Hi.
If you've been, hi, Alan. Hi. Alan has been with us many times, so we've been a follower of the Reactor sessions and especially AI for the past couple of years. Alan has been, you've done numerous of events, but today we are going to be talking about natural language solutions. Hello, Alan. Would you say a few words about yourself?
Yeah. I'm from the north of England. I live in Stockholm, in Sweden, which is usually a beautiful place to live. End of October, beginning of November isn't too great, but it's going to be Christmas soon, so it's going to be fine. It gets really dark here and cold, which it's doing at the moment. But yeah, I work for a company called Active Solution, and we've been really busy with building projects for customers using and leveraging the Open AI services, building internal chatbots and systems where companies can chat with their own data. And it's great to be able to share that knowledge with other developers, because it's really one of the hot topics at the moment, building these types of solutions.
And it's definitely a hot topic right now, hence why we're having this live stream, educating our audience today out there. Thank you once again for joining. Today's session is going to be about 30-40 minutes, and if you guys have any questions, please drop them in the chat throughout the session. We're gonna stop, we'll ask them, Alan will answer them, and we'll have a nice flow. But yes, I will put myself now in the background, and I'll be here if I'm needed. But it's all over to you now.
Yeah. So please, as Erica mentioned, please feel free to interrupt me with questions. It's great because it helps to make everything a bit more interactive. Yeah, so this was the session proposal that I submitted when Erica asked me to do a session on building natural language solutions with Azure Open AI Services. I really hate writing these session descriptions, but I'll let you in on a secret. I didn't actually write that session description. It was actually created by GPT in Bing Chat. And one of the things it's great at is being able to actually create session definitions. And I didn't want it to generate just a free form definition. I kind of wanted it to be formulated according to a specific way that I write presentations. So I normally introduce the topics, what the technology is about. And then I talk about the session I'm going to present. I usually start within this demo intensive session. Alan will show you how to use the OpenAI service and so on. So I normally form that type of format with the session presentations. So what I did, I used something called few shot generation. So I asked it to create a session with this following title. Then I gave it some instructions, so it's not going to just generate any old text. I said the session description must be in the style of the following examples, but specific to the title above. Then I gave it 2 or 3 examples of previous session presentations that I've done, which is a guideline. And you can see that the session description follows this one, saying in this demo intensive session, Alan will talk about the architecture. So in this one, I was talking about the internals of the language model, but it was able to generate that session description. I then said, great, please create an outline for topics to cover a 60-minute presentation. The target audience is developer focused and the attendees are smart and keen to develop the greatest applications using the Azure Open AI service. And it came out with this, which is the actual structure for the presentation, which is pretty good. I'm going to follow mostly along with what it suggested. I'm going to make a few sort of changes here and there to the actual structure. I'm not going to go into too much depth about embeddings and transformers, but I will mention tokens, and I'll go through, and there'll be plenty of demos showing how we can actually build solutions that connect to the OpenAI services. So starting off with the introduction, my name is Alan Smith. I describe myself as a developer, trainer, mentor, and evangelist. I love building things. I deliver a lot of training courses, both public classes, private classes, and also I'm a plural site author as well. I'm also working as a mentor. So many of the projects, I just go in on Slack and basically help people to be able to build solutions and be able to kind of enhance the way that they develop stuff. So I'm mentoring a couple of projects using Azure machine learning currently. And I'm a bit of an evangelist. I like looking at new technologies and understanding how we can work with those technologies. I work for Active Solution, and we're currently AI Partner of the Year. We got this award a few months ago for the customer work that we've been doing with artificial intelligence. I'm also an AI MVP, and as Erica mentioned, I'm very active with organising conferences. We've been hosting the Cloud Burst Conference and the AI Burst Conference at Reactor Stockholm, and I'm also involved with global boot camps. I travel around and speak at conferences. I also work with Coder Dojo, which is kids between 7 and 17 years old, teaching them how to program because they're going to be the next generation that's taking over when we all get too old. And I'm also quite an active YouTuber, so quite a few of my demos I've put out on my YouTube channel. So GPT scenarios, the typical scenario that you get introduced to with using large language models is going into something like Bing Chat and asking a question. So you ask it how to make cheese, and it will come up with quite a good textual description about how to make cheese. So it's great for being able to do this kind of question and answer options. And many of the customer solutions that we're building is doing question and answer solutions, but instead of being on the just on the public internet, they're wanting to do question and answer on their own data. And I'll explain how we can do that a bit later on. Another option is text generation. And this example is actually taken from a customer scenario. We can't actually show the customer code and the customer solution, but it's very similar to what we were doing from a customer. And here I'm giving ChatGPT 4 things. I'm giving it a scenario. I'm giving it a hero. In this case, it's the scenario is the SweetUp conference that was in Gothenburg last week. Magnus and Matthias were the organizers of that conference, so they're the heroes. And the challenge they had was that some of the speakers were getting COVID-19 and having to drop out of the conference. So what they had to do is to fill the empty slots left by sick speakers at short notice. And I was one of those people who basically went in and did the presenters. And it's developed in the style of one of those In a World Where movie previews that you always see as adverts when you get into the movies. And one funny thing here, it did mention that the vacant spots are being filled by a group of evil imposters. I'm currently a Python programmer, and I was at a .NET conference. So I was joking that I'm one of the evil imposters coming in to sabotage the conference. We can also do it with fact validation. Another customer scenario wanted us to validate text against specific facts or specific policies. And here GPT is able to pick out that Stockholm is the capital of Sweden and not Finland, and also that Stockholm was founded in 1252 by Birger Jarl and not 2010 by Peter Ernholm. So it's able to detect any kind of errors in the text. So we can use it for proofreading and text validation as well. Classification. This is one of the tweets about Tekorama, a conference I was in the Netherlands a few weeks ago. And I don't know whether that's positive or negative, but we can use language models to be able to extract the sentiment and be able to do classification on text and say, are they saying good things or bad things in this particular tweet? Another really exciting development is creating what we call co-pilots that can interact with other systems that we've got within our organization, say line of business applications. And here I'm asking it to give me a breakdown of Nobel Prize winners per country in Europe. And if you're a programmer, you'll know that GPT is able to generate code for us. So in this example, we have a table in a database called the Nobel Prize Laureates table. And so when I ask it this question, instead of just providing the answer with a question, the answer is going to be in the database. So GPT is actually creating this SQL query. And it's really clever because the database doesn't have a flag that says whether you're in Europe or whether you're in the US or whatever. It's basically got the list of countries. So GPT has to understand that the countries have to be in, and then it's listing all of the countries in Europe. And then it's performing this particular query, and it gets back a SQL result set. And it's able to then use that SQL result set to be able to provide a text answer of the actual question that I answered there. So this is a really powerful technique, creating copilots, also a more advanced technique. And I will show you some code. It's literally about 10 lines of Python code that's able to query databases and get those types of answers out. So processing text, if we're going to ask a simple question to a language model, the language model architecture looks something like this. This is taken from a white paper called Attention is All You Need that was published a few years ago by researchers at Google. And it really kicked off the whole transformer model and attention model that's being used in all of these large language models. So the idea here is that we feed this in and we get some text coming out. But really, there's a lot more that's going on behind the scenes here. Because neural networks don't really understand text. So all they do is maths. They do floating point maths and calculations with large matrices. And the large language models are incredibly large. They're some of the biggest neural networks that have been created. So what we have to do is to convert the text into numbers. And the first stage of this process is known as text tokenization. And you may be familiar with this if you've worked with language models. You hear that you can have so many input tokens, and the cost is always based on how many tokens you're going to be processing and how many tokens you're going to be generating. So the thing about tokens is that they're common sequences of characters found in text, and it converts the language into numbers that the neural network can understand. So if we tokenize that text, you can see each token is represented in a different color. So most of the tokens when we're working with English are full words. We haven't got any kind of subword tokens. They're all full word tokens. Also, you can see that these tokens is a word, it's prefixed by a space. So instead of having a separate token for a space, these are included in the words because normally we have spaces between words. Things like full stops and commas are also represented, and GPT, we've got one token for space G and another token for PT. And that results in this numeric sequence of integers that we can feed into the neural network. And that is taken up at 45 tokens. We can see that the word the is represented by 464 over here when it's a capital T without a space. And then here we've got a T with a space, that's 363. Then these two, there's have lowercase t with a space in between, and they're both 262. So if we start using Swedish as a tokenization language, I'm based in Sweden, so maybe there's a few people from Sweden watching. You can see that now we've got lots of these subword tokens. Förstå, which is Swedish for understand, is 1, 2, 3, 4, 5 tokens. So using a different language results in more tokens as 83 instead of 45 tokens there. And then if we go to Finnish, you can see that we've got even more subword tokens. The array is a lot longer, and that's going to be 103 tokens. I don't know if anybody speaks Telugu. It's a language that's spoken by about almost 100 million people in India. But unfortunately, Telugu is one of the least economical languages when converting into tokens. You can see that results in 622 tokens, even though there's only 247 characters there. So the language that we're using is quite important when we're working with GPT. And we can analyze the tokens if we go to the OpenAI tokenizer. Yeah, we've got a website. Yeah.
Sorry. David is asking, why is GPT split into 2 tokens?
It's just the way that they analyze all of these words, and they're able to kind of economize the way that we convert the text into tokens. So if I take this text here and drop all of this in, we can maybe see if we've got any subword tokens. So you can see that open is 1 token, AI is 1 token, then apostrophe S is another token. So what it attempts to do is to find kind of the common patterns that we have in text to make it most economical for converting those text into tokens. You can see that tokenization here is split into 2 words because ization is something that can be added on to many different words. Also, we want to limit the token vocabulary to about 50,000 tokens that these large language models are going to be using. So it's just looking for the most optimal way of converting text into integers. And the tokenization is determined when we actually train the model. So this platform.openai/tokenizer, you can experiment with this, and you can see the different tokenizations that are generated for these different models.
Thank you.
So there's this saying that English is going to be the new programming language, and we'll see this when we start to look at prompts and how we use the prompts, and we use the natural language to be able to run with the models. And this graph is showing kind of the amount of tokens we get for these different languages. You can probably see one of your languages on there, and we can see Telugu is way down here. And we can see that English is the most economical language for working with tokens. That's also going to be reflected in the understanding of the
Hi, Ellen.
Yeah.
Me again. Sorry, there's another question from Nicola.
Yeah.
And he's wondering, how is it possible that there are more tokens than characters, for example, in Telugu?
Yeah, I think that's because the Telugu uses like Unicode characters, and it takes more than one token to encode a Unicode character. Now, I was a bit surprised when I saw that, but I think that's the reason that with Unicode characters, with special characters, sometimes it is more than one token per character.
Thank you.
Yeah, good. Keep the questions coming. It's great to have some interactivity. Okay, so this is showing, the performance of GPT-4. We can see that performs a lot better than GPT-3.5. And here we can see the languages and the actual performance. And this is in the accuracy of the models. So models tend to be more accurate when using English, and that kind of diminishes. And this is sort of fairly well correlated to the kind of efficiency of generating the different tokens. So the reason I say this is when we're working with this, we should be writing our prompts in English, because the models are most accurate with English. The billing is based on the number of tokens. So if you're having something that generates 500 tokens instead of 800 tokens, then it's going to be more economical. The throughput of these models is based on tokens processed per second. So it's going to be faster when using English. And also the models have a maximum number of input tokens. So you can actually be limited in how much you can feed into the model, and English is a bit more economical on that. So I'd recommend, even if you're building a solution that works in Swedish, to use the English language. Now, I did do this example just to show how performance is affected by language. I asked it how to make cheese in Telugu, and the actual response that came out was much shorter than as we saw a few slides ago when I was asking it in English. And then the model got a bit confused, and it actually generated images of the frozen characters. It's great that it's got this functionality to be able to generate these, but it was a little confused over asking how to make cheese and then thinking that I requested pictures of the frozen characters. Again, I think we were kind of in the early days of these models, so supporting other languages and providing support for other languages, especially if it's something that's spoken by nearly 100 million people, is going to be something that's going to get a lot better in the future.
Hi, me again. Sorry. There's another question from Gopi, and he's asking, or she, with advancements in tech, will Telugu and other languages become economical?
Yeah, I think I just answered that. I said that yes, in the future there will be hopefully better support for other languages, and I'd imagine that the models are going to get more sophisticated and be able to get better at understanding these. Although we've seen fantastic advancements in this technology, it's only been around for about 12 months, and that's really early days when we think about the life cycle of technologies. And I predict that things are going to get better in using other languages. One of the developments for this is companies are starting to generate GPT models that are based on their own languages. So if you'd like to work specifically with Swedish and the Nordic languages, we have a GPT SW3, which is a language-specific model. And there are, other efforts going to look at working with other languages and training a model that's specific on your specific language. However, GPT-4 performance tends to be a lot better than the GPT 3.5. So I would guess that with Swedish, with GPT-4, it's going to perform better than the open source model that's trained specific for Swedish. Again, it's early days in the technology, and it'll be really exciting to see how this evolves over the next few years. So all the model is really doing is doing sequence prediction. We're saying the cat sat on there, And the only thing that the model will do is predict the next token in this sequence of tokens. This is a challenging problem in AI because these sequences can be of variable length. We can say the cat sat on there, or the king of rock and roll is Elvis, and these are variable length sequences that we're feeding in. Also, we have long-term dependencies. If the cat sat on the floor, and then we say it had just been cleaned, because it had just been cleaned, we can assume that it is referring to the floor. And then if the cat sat on the floor, it had just been fed. It links to fed, and we can assume that it's the cat that has just been fed and not the floor. So understanding these dependencies is something that the attention mechanism and the transformer models are really, really good at. And this is why that development has seen such a leap in language understanding in these GPT models. Also, the order of the sequence is very important. This sentence, the film was not, I should have said the film was not bad. In fact, it was very good. Compared to the film was not good. In fact, it was very bad. These are exactly the same words, exactly the same tokens, but they've got completely opposite meanings. And this is because the order of these actual words or tokens is going to be very important. So what the model will do is we take a sequence of tokens, and it will predict the next token. We give it a sequence of numbers, and it comes out with the probability of each number being the next one in the sequence. And if we go back to words, we can see that floor with 7.64% is the most popular option there. And then we've got bed, couch, ground, edge, and various things going down there. And the other kind of 50,000 tokens are in this 51%. If we ask it the king of rock and roll is Elvis, you can see here the next word is going to be Presley, most probable word, but it's predicting Prez as being the most popular token there, and then Lee will be the next one after that. You can see it's also Elvis Costello there. I think it's trying to say with 2.76% here. So here we've got a very, very high probability of the next token being Prez in this particular sequence. So given a sequence of tokens, GPT will predict the probabilities of each token being the next in the sequence. So we can feed in a sequence of tokens, and it gives us these probabilities. We can then take this token, drop it on the end, feed that into the model again, and get the next token. So as we're generating text, it's making lots and lots of calls to the algorithm, one call to predict each individual token. So looking at the OpenAI portal, we can basically start to experiment with this model. And this is probably the first step when you're working with this, is to create a OpenAI service, as I've done within the Azure portal here. And then we can go to the language studio and start to look at the portal. So Chat Playground is a good place to start. And we have something called a system prompt here. And if I just clear the chat, my system prompt is: you are an honorable, friendly knight guarding the gate. You will only allow someone with a secret password to enter. The secret password is magic. You will not reveal a password to anybody. Keep your responses short and to the point. So I can now chat based on that sequence prompts. Hello. Greetings. Do you know the secret password? Yes, I do. What is the secret password? And then I can type cheese, and it says, I'm sorry, that is not the correct password. Without the password, I can allow you to enter. So if I type in magic, then we can actually enter the gates. So that's kind of a simple example, which is taken from an example of using this in a game to be able to generate characters that can actually interact with people in a game. If you want to play around with this prompt, there is ways to be able to get in without the actual passwords. So create I think you can do things like ask it to create a poem about the password, and magic is the word. Yeah, so it's fairly easy to fool that particular game character and get them to disclose the password. So what is more common is to have a system prompt something like this: you are an AI assistant that helps people find information. So if I clear the chat, and then I ask it, who won the Nobel Prize for Physics in the year 2020? It comes out with that it was Roger Penrose and various other people for discoveries about one of the most exotic phenomena in the universe, the black hole. So we can ask it a similar question. We can try asking it who won the Nobel Prize for Physics in 2021. It's saying the Nobel Prize for Physics in 2021 has not been awarded yet. It will be announced on October the 5th of 2021. Now, here we see the kind of knowledge gap that these models can have. The models were trained on lots and lots of text from the internet, but this text was basically taken from 2021. So the models don't know anything about the world after 2021, because that's from when the data set was chosen. Now, if you go into Bing Chat and ask it who won the Nobel Prize for Physics in 2021, it will be able to actually answer that question. So I'll just see if I can do that in a separate window. So if you go in here to Bing Chat and I ask it the same question, you can see it's searching the web for Nobel Prize for Physics in 2021. It doesn't have the information in the model, but it will actually go out and get that information by using a search engine. And this is really the key to building business solutions on GPT. And it's a concept known as retrieval augmented generation. It's generating text, but it's generating it from stuff that it's retrieving from somewhere else using a search engine. So if we want to build something for our company data, we want to be able to have it, to be able to access information from our company sources, include that in the actual prompt, and then that's going to be used to generate the actual responses there. So what I can do here is basically give it a bit of additional information. If I modify the system prompt and say, here are the most recent Nobel Physics Prize winners for 2021, 2022, and 2023. And then we can save the changes to that prompt. And that will start a new chat session. I can then ask it who won the Nobel Prize for Physics in 2021. And it's able to answer that information because we have specified in the system prompt additional information there. So that's really one of the keys to be building business solutions using these particular technologies. And I've got some demos that's going to show how we can work with those. I'll mention quickly the parameters that we can use, because temperature is an important parameter which is going to be governing the randomness of the outputs that the model will be generating. We also have top P, which is an alternative to temperature. You can modify the temperature or you can modify the top P, but you generally shouldn't change both. Also, you can ask it to generate more than one completion for each input message. So you can maybe select the best completion or give the user a choice of different completions. You can tell it when to stop. So should it stop when it gets to a full stop? Should it stop when it gets to an end of a paragraph, and so on? And you can also tell it the maximum number of tokens, and this can vary the length of the answers that you're going to be generating. You can also penalize it on presence and frequency. So you can make it generate less repetitive text and not repeat certain parameters. If you're generating a song, for example, you want words to be repeated and phrases to be repeated. If you're generating a business report, you probably don't want phrases to be repeated. So those can be modified as well. And you can also bias specific tokens for appearing in the completion by setting a bias on that you want specific words to appear more than others. I've not experimented with that. That's a bit more advanced. So generally, for retrieval augmented generation, we choose temperature somewhere in the middle. If you're creating kids' stories, then use a fairly high temperature. For text classification, you always want the same result. And generating code to call external systems, you generally use a temperature of 0 for that. And then top P is governing the actual percentage from which the answers will come. So a top P of, say, 0.2 is only going to select the first few tokens. And then if you specify, say, 0.4, it's going to select a lot more. And 0.75 will have a much more of a range of tokens that will come out. So a bit about the architecture. The model is basically filtered. We've got an API which is going to govern all of the parameters. We've also got inputs and output filters, which prevent you from typing in, asking it how to make a bomb, or sometimes it will actually generate bad answers, and you see the output filter actually shutting down the conversation. Sometimes that can happen. There's also various things like logging and billing on the API as well. So it's not just the model. There's lots of functionality within the actual GPT service that is being created for us to work with. So what I'm going to run through for the demos is using a Python library called LangChain to be able to develop solutions using GPT chat. Now, if you're not a Python programmer, within .NET, they've got something called semantic kernel that can be used, and you can also program against the API directly using the SDKs. For simple solutions, it can be good to program directly, but for more complex solutions, it's good to be able to use LangChain. And this project here, this GPT API project, is kind of a playground project that we use within our solutions to be able to prototype ideas with. So I'm going to basically close all of the tabs and start with something fairly basic. So we've got this basic examples, which is we've got a prompt template providing a short explanation of a particular topic that's suitable for a particular target audience. So if I run this API, and what I can do is go to Postman, and then we've got the explanation topics. So if we ask it to explain AI, and the target audience is a 5-year-old, it says AI stands for artificial intelligence. It's like a robot that can think and learn on its own, just like how you learn things every day. AI can learn new things too. And if you want it to be more for a advanced developer rather than a 5-year-old, it's going to generate something different and talk about it in much more depth. So for text generation, this is a really simple example where I'm building an API where I can pass in a couple of parameters and get the actual response out. The next example was generating text specific to an example. And what I'm doing for this is I'm doing something called few shot generation. So if I go back to the GPT API and look at the text generation, here we've got these prompt variables, which is the subject, the hero, the villain, and the objective. And I've also got a prompt, which is stored as a text file. And in this one, if I just enable the word wrap, edit, advanced word wrap. Here I'm saying create the introduction to a dramatic, exciting movie about the subject where the hero must battle against the villain in order to achieve the particular objective. And here I'm giving it 3 examples of these in a world where movie titles. And so we've got basically 3 of these that I would like it to generate the text in the style of. So if I drop back to Postman, and that was the one that I used for the .NET conference. So this can be presents about AI for Reactor. The hero is going to be Alan and Erica. And the villain is going to be hopefully we won't get a broken oh yeah, the subject will be Reactor. Yeah, just see what it does with that. So yeah, it's coming out in a world where technology remains supreme. One presentation holds the key to the future of AI at Reactor, but the evil broken microphone threatens to silence their message, and it's able to come up with that actual definition. Now, this seems kind of like just a silly, fun example of generating silly text, but really this is from a customer project whereby they had a website where people were submitting suggestions, and when somebody types something in a website, it's in very, very informal text. And if they were going to go forward with this suggestion, what they needed to do was to create a report, and the report needed an instruction. And the report needed an introduction, which was a really formal summary of the actual point that the customer was raising through the actual website in their comments. So what we did was they had hundreds of examples of these. So what we did was we took a few of the examples of the comment from the website and the introduction to the presentation, and then what we could do is we could just feed in a website comment with the title and the actual text in the comment, and it would generate the formal introduction to the report in the actual style that they were requesting. And that was a really nice example of being able to use this to be able to generate text from an example and save people kind of the tedious work of actually typing out introductions to reports all of the time, and then they can get on with the business of actually being able to do something to help the customers with their particular requests. So another example that we can use is searching and building a Q&A solution. So here I'm asking it, what is RAG? Which and it's telling us that RAG stands for Retrieval Augmented Generation. It's a model that combines non-parametric retrieval of knowledge with parametric generation of text to perform knowledge-intensive language processing tasks. I can also ask it, what is cheese? And send this question in here. So in the information sources do not provide a direct answer to the question, what is cheese? And this is an example of building a solution where we're actually going out to a search engine and getting information and being able to answer questions. So this is a more business scenario. If you look at the implementation for this in the GPT API, I've got this retrieval augmented generation prompt. And what I'm saying here, you are an intelligent agent that answers employee questions. Answer the questions using only the data provided in the information sources below. If you cannot answer the question using the sources below, say that you don't know. And here we've got the question, and what I'm also providing is the information sources. Now, these are coming from Azure Cognitive Search. So in the utils, I've generated a cognitive search retriever that's going to go into Azure Cognitive Search. It feeds in the actual question. It gets documents out of the cognitive search. And the index that I'm using in search is AI White Paper Fragments Index. So this is the cognitive search service that we've got running in Azure. I've indexed a bunch of documents. It's able to search those documents, get back information, and provide the information in the prompt. I mentioned about, English is a new programming language, and we use English for the actual prompts, even if we're going to be answering the questions in Swedish. So I can say modify the prompt, the answer must be. So just try telling it that the answer must be generated in Swedish and just see what happens then. It's coming out in Swedish there. And if I ask it again about retrieval augmented generation, even though the question was in English, and even though all of the source documents are in English, it's actually creating the translation in Swedish of the particular question that we are answering there. So I definitely highlight again that using English as the actual prompting language, and the reason that we mention that English is a new programming language is because we are actually writing a program in English telling the actual GPT model what to do. And then if you look at the, I don't know if I've got an example for the fact validation. Let's just see what I've got in Postman. No, I don't know if I've got an example for the fact validation, but another thing that we can do is use agents, because here I'm asking it, what is the total population of Stockholm and Oslo? And if I ask that question, if we look at the actual command prompt, I'm actually providing it with access to Wikipedia and also access to a calculator. Sometimes it does that. I should really set the temperature of 0 when I'm running this demo here. And what it should hopefully do, let's just run the API again. Provide it with access to Wikipedia and to a calculator. And these tools are known as agents. You can see it's got an answer there of 1,709,000 100,037. And the interesting thing here is really the way that the model is thinking rather than the actual results. I'll just make this a bit bigger so it's a bit more visible. So when we ask it that question, it's saying, I should use Wikipedia to find the population of each city and then add them together. So the action is Wikipedia, and it's got a tool that enables it to actually search Wikipedia. So what it's asking is Wikipedia for articles about Stockholm population and Oslo population. So here we're getting back information about Stockholm and Oslo from these various pages. And eventually it should be able to extract that information. It says, I have found the population of both Stockholm and Oslo. I should use the calculator to add them together. Now, one of the weaknesses of these large language models is doing mathematical calculations. It can sometimes add numbers together, but it's a language model. It's not really a numbers model. But what we can do is we can provide it with a tool, which is a calculator. And then the actual language model is basically feeding in these two figures into the calculator, and the calculator is giving an answer. And then it can use the answer to give out the total population. So within LangChain, we have the concept of agents, and this is Python based. Within semantic kernel, we've also got the option to be able to connect to external systems and retrieve information. And this is when you hear of all of the talk of co-pilots. This is when companies are building systems that can interact with our line of business applications, and they can also use those to be able to retrieve information. So definitely recommend not programming this by hand, using LangChain or using semantic kernel if you do want to build these more sophisticated business systems. And then the final demo. This is one that we're experimenting with, and what I've actually got is a SQL database in Azure SQL that contains information about Nobel Prize laureates. So I'll see if I can actually show the database. So if I go back to the OpenAI demo user group, I think I've got a SQL database, which is this one here. And if I go into the query editor, it's not liking me logging in. I'm just going to check the security on this. Oh yeah, I understand. I'm using it on, I was using it on the developer tier. So it basically shuts down the database when I'm not using it. And now it's started up the actual database. You can see that I've got a table here called Nobel Prize laureates. So if I do select star from and then drop in, can I drag that across there? Oh. IntelliSense will help me out though. So if I just run that query, you can see that we've got this information here on the Nobel Prize laureates with all kinds of information here. And I've taken this data, I've imported it from a website called Kaggle, which is a database of all of the different Nobel Prize laureates there. Now, if I want to query that database, if I'm a SQL developer, then I can start to write SQL. If I'm interested in people who were born in Sweden, I can specify where the born country. Born country is equal to Sweden, and I can query for the Nobel laureates that were born in Sweden. So what we can do with GPT is we can actually use GPT to be able to generate the SQL code to be able to retrieve specific information about that particular database. So if I go to this demo here and run this demo, what I should be able to do is to ask questions about that particular database.
Hi, Alan.
Yeah.
Sorry, you just got 4 questions in 1 minute. Would you like to answer them now, or do you have much left of your presentation and answer them?
I'll just run through this quick demo, and then we can just take all the questions at the end, I think, because it's a fairly short demo.
Cool.
Yeah, so here, I could ask it that question, but instead of asking it in SQL, I can ask it in English. I could say, how many how many Nobel winners were born in Sweden? And it's coming back and saying 30 Nobel winners were born in Sweden. How many Nobel physics winners were born in Sweden? And it's coming out with a 4. And then I can ask it, what are the names of I should have said that were born in Sweden. There it's coming out with the actual names of those. So what's going on behind the scenes is that when I ask a question, the agent, or the actual, in this case it's a SQL database chain, is actually generating SQL queries for me. Now I've got verbose set to false. If I change verbose to true, what we should actually see is the actual SQL that it's generating. The thing that really excites me about this is the actual code that I've written to be able to perform this. I'm connecting to a database, and then this code is just generating that. Sorry, that's linking to my large language model, but this code here is just generating that SQL chain. And it's able to understand the database and be able to make queries against the database just by asking those particular questions there. So there's not really that much code, but the functionality that it's providing is really great. So if we just go back in here and it warms up again. Now here, because I've turned verbose on, if I say many I'm always picking Sweden. I'll choose Italy instead. So here we can see that it's coming out with this SQL query: select count from Nobel Prize winners where born country is equal to Italy. So if I run that against the database, I get the actual results. And then it's coming out with this: there were 18 Nobel Prize winners born in Italy. So I can ask it for their names. Winners that were born in Italy. And you can see that the SQL query is different, that we're selecting first name and surname from the Nobel Prize winners. So the SQL agent is basically able to go to the database. It retrieves the information about the tables in the database. And then from that understanding, it's able to create its own query, run the query against the database, and then get back the appropriate response. This is really exciting. However, it is also a bit frightening, because what's to stop the language model from updating the database? If you ask it for the sales figures for your company, and it comes back with the sales figures and they're not too good, if you ask it to improve the sales figures for the company, it may start updating the database and modifying the database to be able to improve these sales figures. So we do need to be very, very careful when we're using these agents. I haven't done this because this is just a proof of concept project, but you should really think about not allowing the model to be able to actually make any changes or modifications. Give it read-only access on the database to be able to make those calls. But as I mentioned, this is kind of a research projects that we're doing just for looking at how we can use this in other systems. And the thing that really excites me is this technology is evolving so quickly. LangChain hasn't been around for very long. Semantic kernel's only been around for a few months, and these techniques, there are no best practices yet, because we haven't really kind of evolved to a stage where we've got everything laid out about how we should build things. So it's a great area for exploring new technologies, defining best practices, and thinking about how we can build great solutions. Okay, so we've got about 10 minutes left. I'd be happy to take any questions if we've got any questions.
There are plenty of questions, Alan.
Excellent, yeah.
Let's start with the first one. Can you see the screen?
Yeah. By using your own data scenarios to mix text, context, and number if you have a table of product orders. Yeah, this is a bit more challenging to be able to combine a database and textual information that's coming from a search engine. I've not really put those two together, but it should be possible to do that. One of the things about the agents is that they can understand when to use a specific source. So in the example with Wikipedia and calculator, it knew based on the question when it should use Wikipedia and when it should use a calculator. So I'm guessing if you provide it with a database and you provide it with search capabilities, it should be able to decide, say, if you ask it, what is the description of a product, it probably is going to go to the product manual. And then if you ask it, how many products have we sold, or what is the price of a product, then it may understand that it's got to go to a database. But you should hopefully be able to build solutions where it can choose to use the articles or be able to use a database in the appropriate scenario. But I've not really looked into those implementations.
Thank you. And then a follow-up question from Ivan.
Give me the average price of a product one and give me a short summary of the production of product one. Yeah, it should be able to be able to work with averages in the database. It should be able to use the average aggregate in the in the database. I don't know. What is the average age of Nobel winners? I don't know how it will figure that one out. Oh yeah, the average age of Nobel winners is 80.87 years. I think what it's doing is just looking at how long they what the average lifetime is, not the average age of when they won the prize. So it is able to do that. Yeah, give me a short summary of the production of product one. It really depends on the information that it can get. If there is information about that in the database, it should be able to do that. So, for example, I think I can probably copy paste it from the slides when I was asking it about the breakdown. If I just copy this one here. So it's able from that to be able to form a question. Sometimes you can ask it stuff that it doesn't understand. It won't be able to get the answer. But I don't know how it would interpret a short summary of the production of product one if it would look in the database or look in information. But the average price and the sales trends, it should be able to predict fairly accurately.
Thank you. And now next question is from Muhammad.
Yeah, can we get an answer from existing file in projects such as text, JSON, CSV, XML, or JSON? Yes, it is able to parse JSON and XML and CSV. There is, if you're working with Python, there is a pandas agent where you can take in a CSV file, and you can also bring in structured data such as XML or JSON. For looking at text, this is something I forgot to show actually, in that Microsoft does have a number of these sample projects that we can use. So this is one of the links here, and Microsoft is coming out with one of these every couple of weeks or so, where it's actually a starter solution that is using the Open AI service and using cognitive search to be able to build solutions that are using search combined. And this is another example of another architecture that's using a cognitive search as well. So there's plenty of these starter examples whereby mostly we've got our documents in they're either in Word format as PDF files, or they're in they're either in Word format or they're in the PDF format. So we're putting the PDF documents into cognitive search and then querying those documents from those. So that's what we usually do for working with text-based data. But yeah, it is possible also to query text files and be able to search text files as well.
Excellent. Thank you so much. And next question coming up.
Yeah, so LangChain is really a wrapper around various different language models, and I'm using LangChain against the Azure Open AI Service, and it is supported in LangChain there. If I go to the GPT API, if I look at, say, the basic examples. Yeah, I'm just using this LLM model. So yeah, that's coming from here. So yeah, so what I'm saying is from langchain.chat models import Azure Chat OpenAI, and that's basically built to be able to work against the Azure OpenAI service. So I create a new instance of that using the various parameters there. But it also works against the OpenAI service as well. You can also use LangChain against other models as well. So it supports many different models. And here I'm just using the Azure Chat OpenAI option in LangChain. But LangChain doesn't provide the model. It just provides a wrapper around these hosted language models that we can use. So it's a way of being able to call the OpenAI without having to write all of the API calls myself.
Perfect. Thank you so much. And we have another question from Ivan.
Yeah, I mean, it does a grouping query. I think when I asked it the last question about give me a breakdown, you can see here it's using group by born country in order to group the actual results and come out with these actual options like there. So there, it's using group by, and then having, I think, oh, that was in, it was using here. I think it would be able to generate having as well. But it definitely, it's definitely able to do the group by options there. We can see that there.
Fantastic. Thank you. And we have two questions, or same question pretty much, regarding your...
Yeah, I'm really lazy when it comes to putting my examples out on GitHub. Also, the API that we're building, this is kind of what we build internally at Active Solutions. So we don't really want to share this too much. I do use it in demos and show it publicly. We're happy to talk about how the code works. But there is so much stuff available. I would say the best resource is YouTube, to be able to just go through and get a YouTube tutorial on using LangChain. And then within the repositories on GitHub, there's a lot more examples, like the Microsoft examples I'd recommend as a starting point. They tend to be a lot better written and a lot more well produced. So these kind of solution accelerators that Microsoft is producing, these are really the best starting point for looking at building these solutions.
Thank you.
But I will be recording more demos and putting them out on YouTube as well. I probably won't be sharing the code, but I'll be talking through how the code works.
Yeah, and that's great enough. Thank you. And then one last question.
Yeah. I mean, it should be able to handle typos, and normally with GPT, it should be able to understand that if I spell Europe wrongly. Hopefully it's going to be able to figure that out. Yeah. So if I type Scandinavia like that, let's see if it figures that one out. Yeah, so it is able to kind of understand what we mean, even if we don't get things in the appropriate text. I don't know how good it is. If we do something like that, does it still understand? Yeah. So it is able to kind of understand if we get small typos in the question. You can usually recover from those.
Thank you so much. There are no more questions right now. So, and yeah, we are up to 1 hour. So we're out of time now. But thank you so much, Ellen, for this fantastic demo and presentation and answering the questions also well. Looking forward to have you back again another time. It's always
Yeah,
a
and
pleasure.
then we should mention Peter and his prompt engineering session.
Oh, yes, indeed. So in 2 weeks, Ellen's colleague, Peter Örneholm, also from Sweden, Stockholm, will host another session regarding Azure Open AI. So check us out and make sure you register and you join for that session. It's going to be on Monday in 2 weeks at the same time. So yeah, that's from me. I don't know. Any last words, Ellen, before we wrap up?
No, thanks for the opportunity to present. It's really good to get these ideas across as well. And this is something that last week I hadn't built that SQL demo, so things are just changing so quickly and evolving so quickly.
Yes, indeed. Yeah. But thank you so much once again, and guys out there, thank you so much for being so active on the chat, asking your questions. We love to see that when you are proactive and ask questions. It's a great feedback for us, really. So thank you so much. Have a fantastic rest of your day or evening, wherever you are in the world. And I hope to see you soon on another live stream. So thank you so much, everyone.
Thanks. Bye.
Bye.